Chemical Kinetics lecture part 6, and this is the last section of Chemical Kinetics chapter. I will talk about catalyst and the role of catalyst in the chemical reaction, and of course its application, because catalyst application is really very crucial in our daily life. As we know, the catalyst is a substance that changes the rate of chemical reaction without itself used up or consumed. Catalyst can be divided into two groups: homogeneous catalyst and heterogeneous catalyst. Homogeneous catalyst, which exist in the same phase as the reactants, and heterogeneous catalyst, which exist in separate phase from reactants. Before explain the energy reaction progress curve, how catalysts work, let's give one example to understand this reaction. And I want to use the same reaction that we used in the last part when we were talking about the reaction mechanism and understanding how we can understand which one is catalyst, which one is intermediary species, or etc. So let's write the hydrogen peroxide. Decomposition of hydrogen peroxide is really a very slow process, especially uncatalyzed situation. But if we add some catalyst, it works very faster than the uncatalyzed situation. So this is actually the reaction. If we want to make it balanced, so I think I need to add 2 here, 2 to 4, so 2 to 4. So if we here 2, yeah, now this reaction is balanced. So this is the overall reaction. So in the absence of catalyst, it's very slow. So now let's see that what happened when we add the catalyst. The reaction is speed up. Rate of reaction is speed up. So let's see that how the catalyst works and the reaction mechanism for this reaction. So first step, hydrogen peroxide react with catalyst iodide and decompose to water and another hypoiodide oxide. And the second step, this intermediary species, you all know now. If we look into my series of lecture, I hope then you know, it will again work with hydrogen, another molecule of, or again hydrogen peroxide. We never know how many molecules, correct? A percent of reaction happens. We can just hypothetically consider here water plus oxygen plus iodide. So now if we look into the reaction, I'm not going to write in here, but I will change the color and explain and also compare with the diagram that how mechanism of action of catalyst. So let's take the red color. Let's take the blue color. Okay. So here, according to the definition, we know the catalyst never participate directly, but it speed up the reaction and it never used up. So if we look into here, this is the intermediary species and this is the catalyst. So eventually what we have 2 mole overall reaction, 2 mole hydrogen peroxide and 2 mole water plus oxygen. So this is the main thing. When we will study the mechanism of reaction and we will write the overall reaction, then we will find is as it is balanced form. See, now it's a question mark. Then how the catalyst work if it is not used up by themselves? Yes, if we look into this reaction, let's consider this reaction for this hydrogen peroxide decomposition. Here is a uncatalyzed and here is a catalyzed. As we mentioned that uncatalyzed form is very slow than the catalyzed path. So what actually the catalyst do? Catalyst affect on the total activation energy. So in without catalyst or uncatalyzed condition, the amount of activation energy we need to speed up the reaction to make a product, catalyst decreases the activation energy, and as a result the reaction rate is speed up and the more product is formed. If we look into this kinetic energy graph, we can see here that this is the kinetic energy x-axis, this is the catalyzed reaction, and this is the uncatalyzed. So you can see the less kinetic energy is necessary when we use the catalyst. So this is how actually catalyst speed up the chemical reaction without using up. Without using up, you now get here the evidence that catalyst come with the reactants, intermediary IO form, and then speed up the reaction by reacting with H2O2, and once the hydrogen peroxide decompose, make the product, and it again nullify, because if the catalyst used in the reaction, we could see in the overall reaction. If we cannot see any species in the overall reaction, that means this is either catalyst or intermediary species. Now, as we said, the homogeneous and heterogeneous catalyst. So in the heterogeneous catalyst, we saw that the catalyst phase is different from the reactants. So this is the example of Haber process to produce the ammonia in a large scale in the industry. If now we look into this procedure, we will see how here the heterogeneous catalysis process occur, or heterogeneous catalyst work. Heterogeneous catalysis is actually based on the adsorption of the reactant particles onto the surface of the catalyst. Then the catalyst speed up help them to breaking the old bond and making the new bond by doing the collision of reactants, and this is how the new product form and speed up the reaction. If we look into little bit here, you can see the first step. These are the bottom of the iron on the surface of catalyst. These are the iron catalyst, and these are the nitrogen molecule and the hydrogen molecule, and they adsorb there, and catalyst helps to break the bond or dissociate to nitrogen atom and hydrogen atom, and then bonds from hydrogen and nitrogen start to begin. Here bond already forms. Here ammonia molecules are forming, and here ammonia molecules leave the catalyst surface. See? So I just remember when I saw it, I just remembered that in our society there are many people, they will associate with you, they will tell that you are their friend, but only for those moments when they need you. So in that particular example, just like that, they come on catalyst surface, they done their job, and they leave catalyst. So just remember this example, you will never forget this heterogeneous catalysis. As I say that in our daily life, like our body biomolecular reaction, all mostly depends on the enzyme. Even lots of industry use the catalytic reaction, and you can see here this is a kind of called the modern catalytic converter. This is called the modern catalytic converter that nowadays we find in the new car. So all those applications actually the example of catalytic reaction. So that's all for the chemical kinetics, all part 6. I have tried my best to explain detail on the basis of the books that names chemistry, the molecular nature of matter by Jesperson and Hislop, and the 7th edition. Actually, I made the lectures for my students and I also give them the voiceover. So this is the platform that we nowadays all use. So my students will get my direct lecture and also they will have access on this video, and I hope that it will helpful for my students, and if it helps others it will be very appreciating and I will happy for that. And also, as I said before earlier, that I will try to make a practice the other short multiple test, I mean the question answer session in a review sheet, not now but if I have enough time very soon in recent days, so that you will have an idea that what type of problem and multiple choice question can come during the examination on this topic, because chemical kinetics is really a big topic, but once you take a lecture, once you understand, it's really interesting. So that's all for today now.